Hello, hello, hello. Good morning, everyone. Mega love shout out to all the subscribers and followers of this channel. And if you are new to my channel, please don't forget to like, share, and subscribe, and leave a comment on the comment section. Our lesson for today is how to graph linear inequalities. And this is for Math 8, and it's your teacher, Marife Adonis. Solving a linear inequality into variables is like graphing a linear equation with a few extra steps that will be explained on the following slides. Remember that inequalities have infinitely many solutions, and all the solutions get represented using shading. Okay, so these are the key concepts. A linear inequality into variables has a half plane as the set of solutions. A half-plane is a region containing all points that has one boundary, which is the straight line that contains in both directions infinity. So like this, no? So this is the half-plane. Inequality brothers. Okay, so we have here, now this brother is a dotted line, okay, and this is a closed line. So this means that it's non-inclusive or also known as open. This one is inclusive, also known as close. Alright? Here are the steps to graphing a linear inequality into variables. First, graph the inequality as linear equation. So, if the inequality is inclusive, that is less than or equal or greater than or equal, use a solid line. If the inequality is non-inclusive, that is less than or greater than, use a dashed line. Shade the half plane above the y-intercept for greater than or equal to. Shade the half plane below the y-intercept for less than or equal to. Check your answer by picking the test point and substituting it into inequality. The test point in the shaded half plane should give you a true statement. A test point in a non-shaded half plane should give you a false statement. Okay, let's go on. How to determine the type of line to draw? For inequality symbols, so uh, this is greater than, this is less than, greater than or equal to, or this is less than or equal to. So for less than and greater than, you'd use dotted line. And for less than or equal to and greater than equal to, so you have to use solid line. Okay, let's move on. Now choose the type of line for the inequality given. So for example, is this solid or dotted? Okay, this one is solid, no? And for number two, solid or dotted, of course, this one is dotted. All right. Next, choose the type of line for the inequality. Of course, for this one, so we need to use, since it's dotted, so we will use this one, no? Okay, next. What about a solid? For the solid, of course, we will use this, no? So it should be easy for you to understand, okay? Next, if the inequality is y is uh, greater than mx plus b, or y is greater than or equal to mx plus b, the shade is above the line. Okay, remember this, no? If y or the y-intercept, y is less than mx plus b, or y is less than or equal to mx plus b, the shade is below the line. Okay, please don't forget. For example, we have graph y is greater than or equal to x minus 2. So y is equals to x minus 2. So this is our line, no? Since our graph, our y is greater than or equal shade above the line, no? So this one, okay, so from here, this is our shaded area. It should be above, okay, above the line. Next, for y is greater than or equal or less than or equal to x minus 2. So if you are going to graph the line x minus 2, this one here, no? So since it is y less than or equal to, so the dotted line should be below here. Okay, so pababa siya. Okay, or the shaded region. The shaded region is the one there. Do you do anything different when the line is dotted rather than solid? Oh, if I only had a brain. So of course you have a brain. All right, not really. The answer is not really. Okay, let's have a graph. No? So this one graph is greater than x minus 2. So this is the line for y is equals to 2, but make it is dotted, no? Since y is greater than shade above the line, so these are the shaded region, no? So if you're going to put the shade here, okay, so we will more discuss this later, no? As we go on with our lesson. Okay, so this one is y is greater than negative 1 half x plus 3. So the type of line that we're going to use is solid or dotted. What do you think? We will use dotted line here. Okay, next. Okay, so this is dotted line, right? So where are you going to put the line? Is above or down? Okay, so this one is above, right? So above. Next. All right, let's have another example. Graph the solution to the following inequality. Y is greater than x plus 3. What are we going to do with this? Okay, so on the next slide. Graph the inequality as linear equation. Since the inequality is non-inclusive, use a dashed line. Okay? So we can rename that as y is equals to x plus 3. To graph the line, plot the y-intercept form 0, 3, and then use the slope form to the second point. The slope is 1. Count up 1 unit and to the right 1 unit to the flat and second point. So connect the 2 points and extend the line to the edge of the coordinate. So this is how it is. So like this, no? So we're going to graph that. This is the dash line or the dotted line. So you may use dots or dash. Okay. Now shade the appropriate area. Since the symbol is greater than is used, we will shade above the y-intercept. So this one is the half plane that is being shaded. Okay, this part, this shaded region here. Now all of it. Okay, so this gray colors, this is the uh, graph, no, of the y in since of the y greater than x plus 3. Okay. Now, step number 3. Pick a test point above or below the line and substitute the point into inequality. So choose 0, 0 because this point is easy to substitute into the inequality. So if your y is 0 greater than 0, no, your x is 0 plus 3, therefore 0 is greater than 3. So this is false. Since the test point makes the inequality false, all points on the side of the line make inequality false. So therefore we were correct to shade above the line. So yes, we were we're correct. Okay? Okay, so let's have example number 2. Graph the solutions to the following inequality. This is y is greater than or equal to 3x plus 2. Okay, so on the next page, we are going to know how to do it. Alright, so first, graph the inequality as linear equation. Since the inequality is inclusive, use a solid line. So, as the equation, so we have y is equal to 3x plus 2. To graph the line, plot the y-intercept first, that is 0, 2. Then use the slope to find the second point. The slope is 3. Count up to 3 units and to the right 1 unit and plot the second point. Connect the 2 points and extend the line to the edges of the coordinate plane. Okay, on the next page, let's do it. Alright, so since we have here, so it says that our slope, no, so we have the y-intercept is 0, 2, and our slope is 3. Okay, so from that we could say that our point is here. All right, on this line, no, so 2 points because 0, 2, so our x is 0. Okay, so this is our x and y in, of course, so it's 0, and then we will count 3 units, 1, 2, 3, and then 1 unit, so that means our slope is 3. So the next point is here. We are going to try that 1, 2, 3, and 1, so that means the other unit is here, other point. So then let us connect this one. Okay, I can handle the but if you have the ruler, you can do it as a straight line. So it should be straight line, no? And then since our inequality is y greater than or equal to 3x plus 2, okay? That means our graph is solid. That's like our line is solid, and our solution is up here. So we can do that here. Huh? So this half plane here is our solution. You can extend your line, or actually you can shade that. You use this one on the darker color to shade. Okay, okay. So you must have colored pencils, or so this is now different from the line. So you could extend up to here because we need to consume the half plane and then shade it. Okay, you have to do it. So I think you understand already. Okay, so for your journal number 5, write your opinion or reflection. Let's go to the worst form of